All right, so as promised, a walkthrough of your guys' homework. So if you are struggling with any of the scientific notation or the significant figures, that you can watch this guy again and review your homework, your practice, so that you can be doing well in this class. So for our first one, we have 5.401 times 10 to the negative 1, which we talked about in class. If I have 10 to the 2, right, to the second, that's the same as 10 times 10. If I have 10 to the negative 1, that's going to be the same thing as dividing by 10 once, right? So if you need to picture this like fractions or picture this as dividing to help you out with these negative exponents, please do so. So we have 5.401 times 10 to the negative 1. So when I'm moving this into standard notation, this is the same thing as dividing it by 10. So if I divide 5.401 by 10, it's going to give me 0.5401. So that's this number in standard notation. And then I've asked you to underline all of the significant digits in the number. We know that any digits that are a number, not a zero, are going to be significant. So 5, 4, and 1. And any zeros in between significant digits are also significant. So that 0 in the middle is significant. The 0 at the beginning is not. It just lets us know that there's a decimal point here, helps to point it out. So our number of significant figures here for this first one is 4. Our next problem, 0.3578. For our scientific notation, I'm going to want that to be 3.578 times 10 to the something. In order to move from 3.578 to 0.3578, I would need to divide it by 10 once, right, to move the decimal 1 over. So that means it's times 10 to the negative 1. My significant figures, all of these digits are non-zero digits. So that means all of them are significant. The 0 at the beginning is not. So that would be 4. Our next problem, 100,678. Just like the rest of these, I want one digit, a decimal, and then the rest of my digits. So 1.00678 times 10 to the something. In this case, in order to move from this number to this number, I'm going to need to multiply by tens. 1, 2, 3, 4, 5 times. So that would be 10 to the 5th. My significant figures, all of my non-zero digits are significant, so I'm going to underline those to start. My zeros in between other digits are significant, so that leaves me with 6 significant digits. For 6.78 times 10 to the 4, I'm going to be multiplying 6.78 times 10 to the by 10 4 times. So this is going to be a big number. So if I'm moving it, the decimal place over 4 times, I'm going to end up with 678 followed by 2 zeros, which is going to be 67,800, right? And because we started in scientific notation here, figuring out our number of significant figures should be easy. Our scientific notation should keep our significant figures. So we should have 3. Let's just double check over here. Our non-zero digits are significant, so we have 6, 7, and 8 are significant. These zeros just tell us our placeholders. They are not significant. They are numbers at the end of a number, but not after a decimal point, so they are insignificant. They're not significant numbers for us. Our number of significant numbers is 3. Next, 5 million. 5. And then that question of, do I have 5.0? Do I just have 5? So we'll look at our significant figures. Here, our 5 is significant. The rest of these zeros are not. If I had a decimal point right here, they would be. But because it's just the 5 and then our zeros are to the right of the number with no decimal point, they are not significant numbers. So I have one significant figure. I'm just going to keep that one significant figure when I move into scientific notation. So 5 times 10 to the 1, 2, 3, 4, 5, 6 zeros. So 5 times 10 to the 6. If you're tripping up between negative and positive, right? If I multiply 5 by 10 6 times, that's going to give me a really big number. These two numbers should be equal. 5.9 times 10 to the negative 2. I should be getting a smaller number because my exponent for my 10 is negative. So I will have, move it back twice, right, for those who need to see it visually, 0.059. Our 5 and our 9 are non-zero digits. Those are significant. I have two significant digits. These zeros are not. They are just placeholders. Next, 23.78. These are all non-zero digits. I can see that right away that those are all significant. For my scientific notation, 2.378 times, just need to move this decimal point once, 10. Just a note, usually we don't do this, right? I put this in for practice, but when we are actually working on numbers in science and in math, we wouldn't write something as 2.378 times 10. That just feels really weird. We would just leave it as 23.78. 1 times 10 to the negative 6. My exponent on my 10 is a negative. That means this is going to be a really small number. So then have 0.0000001. If you need to draw out your loops to show how many spaces you should be moving, you can. But I know that I'm moving my 1 6 spaces. 1, 2, 3, 4, 5, 6. It's moved 6 places in my number through that 10 to the negative 6. I look over here, I only have one significant digit. Over here I look again, my non-zero digit is significant. My zeros here are just placeholders. They are to the left of a number. If my zeros are to the left of a number, no matter what, they are not significant. They only have one significant number, one significant digit. Next, 567.000. These zeros are to the right of the decimal point and to the right of the number. They are significant. So I want to keep those when I move into scientific notation. 5.67000 times 10. You see me counting over here. 1, 2, 10 to the 2, right? My significant digits are all of these. My non-zero digits are significant. My zeros at the right of a number that come after a decimal or between the number and the decimal are going to be significant. So all 6 of these are significant. Next, I have 0.000006 and 0.0000600. I'm going to kind of do these at the same time. First, I want to figure out my significant figures. We did this one in class together. My non-zero digit is significant. All of these zeros to the left of my number are not. They are just placeholders. My zeros to the right of my number that are after a decimal point are also significant. So here in the first example, I only have one significant digit, just the 6. Well, in the next one, the 6 and the 2 zeros following it are significant. This lets me know that I am really sure that it is just a 6 and not like 0.000061, right? Maybe. This lets me know that I'm really sure that these are the next 2 digits. That's why they're significant. Moving into scientific notation, I want to keep my significant digits. So this one would be 6 times 10 to the negative, because this is a really small number. 1, 2, 3, 4, 5, 6. 6 times 10 to the negative 6. This one would be 6.00 times 10 to the negative 6, so that I'm holding on to those significant digits. 5.00 times 10 to the negative 3. This is a negative 3 on my 10. That means I'm going to be going to a smaller number. I'm going to have 0.00500. I want to keep all of these digits here, right, because they are significant. 3 significant digits. Finally, we have 007. 007. Neither of these zeros are significant. Yes, I threw them into tricky so you could have some practice. Zeros to the left are always not significant. Our 7 is significant. We have one significant digit. This would be, in scientific notation, I could just write 7, but we also talked about that I could write this as 7 times 10 to the 0. Remember, if I have 10, if you're wondering again, why does 10 to the 0 work here? If I do 10 to the 8th divided by 10 to the 2, I could also write this as 10 times 10 times 10 times 10 times 10. 8 times. 1, 2, 3, 4, 5, 6, 7. 8 over 10 times 10. 2 of my 10s would cancel out. I would end up with 10 to the 6th, which is the same thing as 10 to the 8th. This 8 minus this 2 gives me the 6 here. If I just do 10 over 10, 10 to the 1 over 10 to the 1, 1 minus 1 is 0. This would be 10 to the 0. We also know that 10 over 10 just equals 1. Okay, so any number to the 0 is 1, but for us, when we're looking at scientific notation, this is going to be 10 to the 0 if we're multiplying it by 1. Again, just like way up here where we had 2.378 times 10, 7 times 10 to the 0 isn't something we're going to see normally. It's a little bit of a tricky question, just to help you guys kind of see the nuance or the details in scientific notation. A note about your notebook. If the discussion about exponents is something new to you and you want to have notes on that, or if you want to jot down the rules for all non-zero digits are significant, zeros in between non-zero digits are significant, zeros to the left are insignificant, zeros to the right are only significant if there's a decimal point, right? So like these zeros are not significant, but these zeros are. If you want to list those rules for yourself in the margins of your notebook next to your practice, this practice will be going on page 12, that's a totally awesome use of this extra space. So I hope this video was helpful to you if you're struggling with your homework.